sir. I guess we're supposed to be on the other side of you.
Oh, right behind.
All right, everybody ready? All right. All right, well, here we are out here at the David Tippin water treatment plant. And we here in the community, not just the city of Tampa, but Hillsborough County and the entire region, want what's best for our community, and that is very, very high quality water that we provide to our citizens each and every day. And so we're out here today to talk about a new technology, a 6 program that we have piloted. We are the first in the nation to adopt this technology, and we are also, now that we have put it into production, the largest user in the entire world. So it's very exciting. A lot of eyes are on the city of Tampa and our amazing water team at this very point. Now, what does this 6 program do? It treats our water, and it reduces the amount of chemicals that we have to use to treat the water, and then it also dramatically reduces the sludge, which is a byproduct of water treatment. So those are 2 great examples of what it does. Most importantly is it reduces the PFAS in our water. We all know that the EPA is doing another round of raising the limits of PFAS that are allowable in water. And PFAS comes from, as we all know it, the forever chemicals. They come from all types of things. They're in our clothing, they're in cosmetics, they're just in just about every aspect of our lives each and every day, and they are minute particles that are very difficult to filter out. So we're very excited about our 6 program. We are also involved in litigation, which a number of other municipalities and other agencies are nationwide about concerning PFAS. And so we are hopefully going to be wrapping up some of that litigation soon. And it also affects or is focused on the PFAS that is in our water supply. So we are going to go forward with this 6, and it's very, very exciting program. Again, the eyes not only of the nation but of the world are on these innovative steps that we're taking in the treatment of the city of Tampa's water. So very, very exciting news, and we are going to bring up now Sarah Burns, who is the Tampa Water Department Capital Improvement Program Director, and she's got a lot more scientific details than I can imagine. Come on up, Sarah.
Thank you so much, Mayor Castor. Good morning, everybody. Thank you so much for being here. I'm very excited for the opportunity to talk to you today about PFAS and about the implementation of the 6 process, which is an innovative version of ion exchange, which has been around for 80 plus years, and it was developed by a Dutch utility. I'd like to start by providing some background on what PFAS are. These per- and polyfluoroalkyl substances are man-made substances that persist in the environment because they have very strong chemical bonds. They originated in the 1940s, and they have many properties that make them really attractive in manufacturing. You can see all these examples of items that contain PFAS on the table over here. As the mayor mentioned, they're in cosmetics, they're in your clothing, they're in nonstick cookware and food packaging. They're even in those wonderful straws we all started using to save the sea turtles, those paper straws. The only reason those don't disintegrate when you're using them is because they're coated in a PFAS-containing substance. With how ubiquitous PFAS is, it should come as no surprise that only about 20% of your exposure actually comes from your drinking water. The remaining 80% comes from all of these other avenues of exposure. As drinking water providers, we are passive receivers of PFAS. That means we don't produce a single drop of it. It comes to us through our source waters, and now that the EPA is looking at their first ever regulation, we're going to be responsible for removing it. We are expecting this first regulation to come out in early 2024. And as the mayor mentioned, we are currently involved in litigation against manufacturers of PFAS in order to recover damages associated with PFAS being in our source waters. We are hopeful that this will generate funds that will help us execute our framework for addressing PFAS. The regulation is anticipated to be set at 4 parts per trillion for 2 of those PFAS chemicals. For context, 1 part per trillion would be equal to 1 drop in 20 Olympic swimming pools. We are testing PFAS levels at the city as part of the EPA's required program, and we're also doing some of our own testing that is voluntary in order to increase our knowledge base. Testing so far has shown that levels in the river are typically below the limit, but we do have some examples of it being above the limit that we're expecting. A challenge with PFAS removal is that organics in the water prevent technologies from removing PFAS. And what are organics? Organics are compounds that contain carbon, or the element of life. For example, when vegetation decays, that contributes to organics being in our water. Removal technologies for PFAS, they want to remove those organics before they will remove PFAS, which means we need to draw out those organics first, and that's what 6 does. So 6 is a very important first step in our plan for removing PFAS. Once we remove organics with 6, the ability of our carbon filters, with some upgrades to remove filters, we're hopeful that that will get us to below the limit. We're currently developing a testing plan to evaluate the effectiveness of this approach for removing PFAS, again, to below the expected limit. So we know that 6 is going to help us address PFAS concerns, but as the mayor mentioned, there are many other benefits of 6. It was originally piloted by the city because of its reputation for organics removal and the associated benefits, because you see organics are problematic well beyond PFAS interference. They affect a number of drinking water treatment processes and can impact the safety of our drinking water. If the 6 pilot was successful and it showed that we can reduce organics from our source water by about up to 90%, which is a 40% improvement from where we are right now. The benefits of this include substantial chemical use reduction, which helps with safety and reduces chemical costs by $1.4 million every single year. 6 is also expected to more than double the capacity of our filters, which will save the city from having to expand our facility beyond its current boundary into the Rogers Park Golf Course, but still will provide the desired capacity. So in short, having 6 as the first step in our drinking water treatment process improves the water quality, it improves the performance of the entire plant, it reduces costs, and it makes the facility easier and safer to operate. Because of these benefits and the non-proprietary nature of 6, many other utilities are interested, including our Tampa Bay Water, which has piloting and 6 in their capital improvements plan right now, and Miami-Dade has also expressed interest in 6. The takeaway here is that this technology is the right fit for our community, and it will help us continue to deliver quality drinking water that meets and even improves upon all federal and state regulations. So with that, I'll go ahead and take any questions, and I have Rory Jones, our new Water Department Director, and Vinnie Hart, who's part of the Tip and Water team, here to assist with that.
So 6 is not here yet, right?
It is.
It is here.
No, 6, we piloted 6, but it's going to be right here where we're standing.
Yep.
And it's going to be that image there?
Yeah, where the... Yes, it's going to be right here. It's not shown, but it will be right here. We'll take up almost all of this space that we're standing in and over that way as well.
And when is
That-
So we would look to start the design in 2024 with completion of the design 2 years later. Given some sequencing of construction and other projects going on, we wouldn't look to start construction until 2028.
So the technology is being used right now. You don't have its own plan
Sorry, and else
for it. Technology is being used right now, but you don't have your own building for it. Is that right?
We're using the 6.
we are not using 6 right now. Other utilities are, and Vinny, if you want to provide some.
Sure. The Ondijk plant, which is the 32 million gallon a day plant in Amsterdam, has been using 6 for 10 years. There's the Mayflower plant in the United Kingdom has been using 6 for 3 to 4 years. So there are large full-scale installations up and operational, and those are what we're going to be using as go-bys for our design efforts.
So I just wanted to ask, how did Tampa, or how is Tampa going to become, of all these cities in the world that have to do this, how did Tampa become among the first, or potentially the first?
It was largely out of really looking for other options. When we went through the piloting process, we didn't want to be stuck with proprietary resin. And that's when our Tip and Water team did offer some suggestions, which we looked to pilot, and that's where we learned the success that it had. But it was really born out of looking for other resins that weren't proprietary.
Give us your name.
Rory Jones, R-O-R-Y.
And to add to that, there were some, because it was developed by a utility in the Netherlands, which is great. Winnie, you can explain this a little bit more, but essentially other utilities weren't as lucky as we were, that we knew about it and were able to work with these companies at an early stage to get it over here. But there were some challenges, and that's why you don't see it in other places in the U.S. yet. But there's a lot of interest, so we're going to see this change very quickly. And being in early is great in terms of supply chain and a lot of other areas. So we're in a really great position. So I don't know if many of you want to add to.
Yeah, just add, one of the struggles with bringing the technology to the U.S. was because it was invented by a Dutch utility, they couldn't do business with a U.S. engineering firm or a U.S. utility. Since then, they've divested and sold to a vendor, so now a lot of those obstacles are out of the way, but that's what kind of inhibited the technology from being brought to the U.S.
Mayor, can you just explain, the next 20 years or so, 25 years, water is going to be much more scarce. It's going to be one of the biggest challenges cities face.
Yes.
How does our city continue to get clean water, provide
Yeah.
clean water, and how big of a challenge is it?
Well, I firmly believe that water is going to be the most precious resource worldwide in very short order. We have a finite amount, and we have a growing population if you're talking about our particular community here. We provide water. We have a permit to pull water out of the Hillsborough River. We have a permit to provide all of our city and a third of Hillsborough County with that water. And so we're doing all that we can to be very, very resourceful and very innovative in how we utilize our water and how we ensure that we're saving as much water as we possibly can for reuse, to stop saltwater intrusion, to replenish our aquifers. And it is something that we need to focus on today, because we can't wait until you turn on the faucet and no water comes out to try to make decisions for our future. Any solutions for providing more water for our community are going to take at least a decade to put into implementation. So these are things that we need to think about the future today.
Brad, isn't Tampa leading the way in terms of conservation? How do you stack up compared to
I'm Brad Baird. Yes, we in Tampa are leading the way in conservation. We have had a program in place since 1988. And I would say that the Tampa Bay area in general is leading the nation in conservation. Conservation is something that we definitely will focus on more and more as the water demands increase in Tampa due to growth. And the Tampa Bay area in general uses less water per capita than many people or many areas across the country.
What's the price tag?
We're looking at $200 million in that ballpark. $200 million. That's for the wells and construction of the 6 treatment process itself.
And also, as you know, when this administration first came in back in 2019, one of our first large projects was the pipes project. And we are replacing wastewater pipes throughout the city in those areas most needed, those pipes that are 80 to 100 years old. And that is a way of conserving clearly through the water pipe leakage. And I would also encourage everyone here to take a tour of all of the projects that are being done out here at the water treatment It is nothing short of fascinating. I spent a couple hours out here last week going through, and it really is a lesson in how we pull water out of the river and turn that into some of the best drinking water in the nation, and do it in a very, very efficient way. And we're continuing along those lines with our pipes program in the conservation and the quality of water, and innovative approaches to be able to conserve all of our water through water reuse to provide as drinking water for our community. All right. Tours will be lined up soon, and no cost.
I thought I heard during the presentation that PFAS levels were low in the river, but you're expecting it to be high at some point.
No, I think that was Sarah. I'll let her.
Thank you. Yeah, so they are. There are 6 different compounds we're measuring as part of the regulation coming through, and we are typically below the limit, but sometimes we have been above the limit.
Are there certain areas, or?
It's all in the source water, so it's being measured both in the source water that comes into the plant and then in the water that's going out of the plant, and we are very slightly above that proposed limit every so often. And I'll add to what Rory said with the cost. Because this process, it has so many benefits, and it improves the capacity of everything downstream. There's a $200 million price tag, but it actually saves us about $250 million of what we would have to do if we weren't implementing 6, because we would have a much larger footprint downstream.
Is it already funded? Yeah.
It is part of the pipes.
The
Yeah.
pipes program.
Yeah, go ahead. Go ahead.
Yeah, so it is part of the PIPES program.
And I'm going to ask the question, how does it work? Can you just tell me simply how does 6 work?
Do you want to take this, or do you want me to?
This is,
There's going to be a test. when
Yeah.
this is
Sure. So unlike other ion exchange technologies, it's a continuous flow system where we add ion exchange resin, we give it time to interact with the water, about 20 minutes, then we settle that resin out and we regenerate it and we feed it back into the front of the process at an even rate, so we get nice consistent water quality coming out the tail end. That's one of the value propositions of 6, is its consistent water quality and the ability to use the ion exchange up front in the process instead of at the tail end like historically it has been.
So I'll add to that. So essentially we have these resin beads, which I meant to bring some with me, but I don't have them. And the beads they have chloride ions around the outside, so they're stuck to it. And then when they come in contact with the water, those jump off and contaminants instead stick to the resin bead, and then we move it into a cleaning process. And then you use salt water to clean it off, and all of those contaminants end up in the waste stream, and you can reuse that resin bead. It sticks, chloride ions stick to it again, and it can go back in and clean the water again.
So you're,
Does-
there you go.
You're,
Shows those beads how they work.
Yep.
I think it's with the release.
And then you can reuse them.
yeah, the
right?
regen
Yes.
is really cleaning that resin, so it's being ready for the next go around.
It's it's a simplification of it, but yeah, that's essentially what's happening.
Yeah, I'll give it to you guys because that's how it got to me. So they're resin balls. They attract the pollutants, and then that is taken away in the waste stream, and then they can clean the resin and reuse them again. So it really is fascinating, and it's as far as I know, very cutting edge and very innovative.
Thank you.
There's still going to be a test. Yeah, until you pass it.